Assalamu alaikum warahmatullahi wabarakatuh. Welcome to Wisdom International School's digital classroom for mathematics. Children, we are going to continue with this mensuration chapter. Okay, so we have already completed the simple figures, right? The area of a square, a rectangle, circles, parallelogram and triangle. These 5 figures we have already seen. The area and perimeter formula, it was already learned actually in junior classes, right? So now we'll learn about more a few figures. Okay, so let's figure out what is the area of a trapezium. So when I say area of a trapezium, this is the figure. Okay, for area of a trapezium, we have one of the sides parallel to each other. See, when all the 4 sides are parallel to each other, when the opposite two sides are parallel, see, like if this and this are parallel and this and these are parallel. See, like in this case, let us say in this case, you have in this will be called as a parallelogram because the opposite sides are equal and parallel. See, these two are parallel and these two are parallel to each other. But if only one of them is parallel, the other one is not, then it is called as a trapezium. Okay, so that is the difference between the parallelogram and a trapezium. In parallelogram, both the opposite sides are parallel. Here only one set is parallel, the other one is not. So you see that B1 and B2 are parallel. See, I have given B1 is the base one, the other one is base 2. Okay, we call them as base because it's like a flat parallel surface, right? The other one is not parallel. See, these two are not parallel. So we don't consider this in the formula at all. So you know that the area of a triangle is half base times height. So this is similar to that, but then we'll be having half base 1 plus base 2 times height. Okay, instead of just one base, we have 2 bases. That's it. Okay, now so that's the formula. Okay, you have to memorize it. Now come to area of a quadrilateral. Some quadrilateral. Okay, like here when I say quadrilateral, none of them are parallel. Okay, not even a single opposite pair is parallel. Okay, you can see that the red lines are all, none of them are parallel, right? So here in this case, what you do is you don't need all these 4 sides. These things are not needed at all. We need a diagonal. This is what is the diagonal. Okay, the D. See, this length of this diagonal is called, it is given by D, small d, and the height from there, height in the sense it should be perpendicular. Okay, so the height of these two lines are called as H1 and H2. Okay, so the area of a quadrilateral is half into D H1 plus H2. So this is the formula of a quadrilateral. Okay, now there is another special quadrilateral, that is a rhombus. Okay, we are going to talk about rhombus. This is the area of a rhombus. This formula is for rhombus. Okay, rhombus. Okay, now this in rhombus, all the 4 sides are equal and also the diagonals intersect each other perpendicularly. Okay, like this. Okay, exactly in the middle, like this. And they bisect each other also. Bisect in the sense they divide each other into 2 equal halves. Now the formula for area of a rhombus is half d1 into d2. We don't have to find the height here because that itself is the height. See, it's d1 into d2, that's all. Okay, d1 is this whole thing from here to here and d2 is the whole thing from here. Diagonals length, both the diagonals length multiplied with each other. Now if I ask you what's the area of a polygon, polygon is like any sided figure. Okay, like this, like you see these two figures, 9.15 and 9.16. now here these are not a quadrilateral. It's like quadrilateral means it should have only 4 sides. Okay, but this has got so many sides, right? So in these cases, what you should do is, we have already learned area of trapezium, area of triangle, and the quadrilateral, area of a quadrilateral, right? So we are going to use that, all those 3 into this. Now when you have got such a figure, a random figure, and you are not able to have a particular formula for that, so what you do is you try to break it into either triangle or trapezium. Like you see this figure A, B, C, D, E. This figure was divided into so many things. See, they have made this is one triangle. Okay, there is another triangle and there's another triangle. So there are 3 triangles. So you can just find the area of the first triangle, the second triangle, and the third triangle. Okay, using these 3, when you find all the 3 triangles and add them together, you can get the area of this whole polygon. Okay, so area of triangle 1 plus triangle 2 plus triangle 3 gives you the area of this whole figure. Okay, area of figure 9.15. Okay, now you come to the next one, area of figure 9.16. If I try to break it, you see I have a triangle. AED is one triangle. Okay, ABC is another triangle. Okay, and this thing GCD is the third triangle. But you see, in between you are actually getting a trapezium. This is a trapezium. Okay. So area of figure 9.16 will be area of triangle. So I'll write triangle 1 plus area of triangle 2 plus area of triangle 3 plus area of a trapezium. Okay. Trapezium, that is FGCB is the trapezium. So you will have to break it into so many halves. You try to break it into a triangle and trapezium, and you already know the formula for triangle and trapezium, right? So you have to use that and add them up. That will give you the given figures area. Okay. So now we'll do few problems from exercise 9.2. So look at this. The shape of the top surface of table is trapezium. So they have given that this is a trapezium. Find its area if its parallel sides are 1 and 1.2 meters. So that's all given to you, and the perpendicular distance is given as 0.8. So area of a trapezium is half times b1 plus b2 into height. So this was the formula we used. So we have to use this formula, half 1 plus 1.2 into 0.8. So that's going to be half into 2.2 into 0.8. So you can cancel this 1.1. So you have to just multiply 1.1 into 0.8. Okay. So that's going to be 88. There are two numbers after the decimal point. So 0.88 meters square. Okay. Now come to the next one. The area of a trapezium is 34 meters square. So here the area is already given. Area is equals to 34 centimeters square, and the length of one of the parallel side is 10 centimeter, and its height is 4. So the height is 4. They are given. H is 4. The other one of the side, let's say B1 is 10. We don't know which one, upper one or lower one. It doesn't matter. Find the length of other parallel side. So they are asking us to find the B2. Okay. So we know that area of a trapezium is half into B1 plus B2 into height. Right. This is your area. So you can write half into B1, you can write it as 10, B2 we don't know, so we'll write it as B2 itself, into height we'll keep it as 4, is equals to area is 34. Okay. Now you see I can actually cancel 2 2s are 4. So I have 10 plus B2 into 2 is equals to 34. Okay. I can move the 2 to the other side, right? So when I move the 2 to the other side, I will get 34 divided by 2, which is actually 17. Okay. Now I need to find the B2. It's going to be 17 minus 10, which is 7 centimeter. Okay. So now since one of them is 10 centimeter, the other one is 7 centimeter, I know that the upper one is 7, the lower one is 10. Right. Now come to the next question. Alright. Here it says length of the fence of a trapezium shaped field ABCD is 120 meters. So length of the fence. So this means they are talking about the perimeter. Okay. The perimeter is 120 meter. Okay. It's like, in the trapezium shaped fence is being built. Okay. That is 120 meters. Now if BC, so let's draw ABCD. Okay. Let me just draw a figure. I'll draw it over here. Okay. A, B, C, D. So I have this fine. This one is A, B, C, D. Let me keep it as D over here. Okay. Now here they say that AB, if BC is equals to 48 centimeter, CD is 17 centimeter, AD is 40 centimeter, and find the area of the field. So we need to find the area of this field. Okay. And side AB is perpendicular to the parallel sides AD and BC. So they are telling you AD and BC are the parallel sides. AD and BC. So we need to draw it again, you know. This is not the right figure because, you know, they are saying that AB, AD and BC are the complete parallel sides, okay. So let us draw it like this, and they are also saying that side AB is perpendicular to this, okay. So there's one side which is perpendicular, something like that, and AD and BC are parallel to each other. So I can say AD, BC. So A, B, C, D. See, AD and BC are parallel to each other, and AB is perpendicular to, perpendicular to this, right? Okay. Now they are saying what is what is your BC? Your BC is given as 48, and your CD is given as 17, and AD is given as 14. Okay. Alright, so now what is this going to be? So they have already given perimeter is 120, right? So this is, you will say that AB plus BC plus CD plus DA should be equals to 120, right? So AB we don't know, we are going to find AB, plus BC is 48 plus CD is 17 plus DA is 40, should be equals to 120, right? AB plus, now let's add this. So 8 plus 7, 15, 8, 9, 10. 105 is equals to 120. Okay. Then you have AB is equals to 120 minus 105, which is equals to 5, 1, 15. Right? 15 centimeter. 15 meter. So this is 15 meter. But since it's perpendicular, this turns out to be our height. Very important to note. Since it's a perpendicular this thing, okay. So we can say area of the trapezium is equals to half B1 plus B2 times height, which is equals to half. What is our B1? Our B1 is 48 plus 40 into 15. So you just have to, you know, solve this, multiply all these things, solve this, and let's see what you get. So you get 88 into 15. So you get 244. You get 44 into 15. Right? The area of this field. So that's going to be, so you can multiply 44, 15 into 44, 5 4s or 5s are 20, 4 1s are 4, 5 6. So you get 6. Sorry. Meter square. This is the calculation. So you can just check the calculation, okay. Now come to the next question. It says the diagonal of a quadrilateral shaped field is 24 meter and the perpendicular dropped on it from the remaining opposite vertices are 8 and 13. Now find the area of the field. So it's a quadrilateral, we know. So you see on top we have written the area of a quadrilateral over here. Area of a quadrilateral is half D into H1 plus H2. So now if we come over here, this is your D is 24 because this is your diagonal, and these two are your heights, okay, H1 and H2. So your H1 is 13 and your H2 is 8. So you just have to use the area as half into D into H1 plus H2. Okay. So that's going to be half into D is 24 into 13 plus 8. So 2 12s are, so you get 12 into, this is going to be 21, right? Okay. After this, we just have to multiply this. 21 into 2. So 12 ones are 12, 12 twos are 24. Okay. So that is the thing. This is going to be meter square or centimeter square. So now we come to the next question. The diagonal of a rhombus are 7.5 and 12 centimeters. So D1 is 7.5 and D2 is 12 centimeters. Okay, find its area. So area, we know that it's half D1 into D2, right? So you just have to do half into 7.5 into 12. So 2 6 are 12. So that's going to be 7.5 into 6. So you can just multiply this. 6 5s are 30 6 sevens are 42, 43, 44, 45. And there's one number after the point, so you can put a point. So centimeter square, centimeter, right? Yes, centimeter square. So that will be the answer. So complete the remaining problems also. If you have any doubts, you can always ask me. Okay, you can send me a message. So this is the answer for this. Okay, so I hope you people have understood it. It's just simply using the formula. Read the question carefully and then understand what they are actually asking you to do, and then use the formula. You already know the formula. I have given you the formula. So first memorize those formulas and then use the formula according to the question, and then substitute it and solve it. Alright, that's all for this week. I'll see you with the remaining of this chapter in the next video next week. Alright, Allah Hafiz. Thank you.